Okay, in the next two videos, we are actually going to talk about our Unit 10, which is vectors. I'll also add some parametric equations in there, but the next two are focusing on vectors. There are a lot of outcomes here, pretty simple to do, and like we said, if you're going into BC Calc, it's extremely important that you're at least comfortable with the basics, so that we can use those later on in calculus. So, vectors or vector quantities are quantities that involve both the magnitude and direction, so you can think of applications. So for example, you're driving due north at 50 miles per hour. The magnitude is the speed, and which is 50 miles per hour, and the direction of the motion is due north. And there's scalar quantities or scalars are quantities that involve magnitude but no direction. So if you just left a room at a 75 degrees, the magnitude is 75, but there's no direction. It is a directed line segment, or array. So we have an initial point here, which is P, and a terminal point, which is Q. For this, you could use your geometric labeling for this ray, which would be from P to Q with your little ray symbol on top. Or you can use capital bold letters, and I say bold so that we know it's a vector. So we are going to go ahead and show that. Okay, so two ways you could write this out would be like you did in geometry, PQ with the ray above it, or you could do a really bold P and a bold Q. Okay, either way. Magnitude is the length of a directed line segment, so think distance formula. Two vectors are equal if they have the same magnitude and the same direction. So A, U, and V are the same. They have the same magnitude and same direction. V and W have the same magnitude but different directions, so they are not. V and W have the same magnitude but opposite directions, so again, not equal. And then vectors V and W have the same direction but different magnitudes. Okay, so in this case, only the first example is an example of equal vectors. Okay, so here's what you need to do. To show that U and V are equal, you need to find the magnitude or the length of each of those vectors, and then you also need to find your slope and kind of compare it that way. So we are going to show the magnitude of U, and magnitude is absolute, almost looks like double absolute value bars. Okay, so 2 bars on each side. And we're going to do the distance formula here. So if I label my points, I have -3, -3. And I have 0, 3. So distance formula is x2 minus x1 squared plus y2 minus y1 squared. So we get the square root of 9 plus 36 when we simplify that, which is the square root of 45. You can break that down to 3 squared of 5 if you would like, but you do not have to. Okay, we're just going to see that they're equal. Okay, points for V. To find the magnitude, we have 0, 0, and we have 3, 6. So if you're going to find the magnitude of V, you're going to do the square root of 0 minus 3 squared plus 0 minus 6 quantity squared. And you get the square root of 9 plus 36, which is the square root of 45. Again, this is why I said it doesn't matter if you break it down or not, because once we get the square root of 45 for both, we know that the lengths are the same. The next step is to find the slope for each of those. So we can make sure that they're going the same direction. So we are going to go ahead and find the slope of U. So we're going to do y2 minus y1 over x2 minus x1. Okay, we get 2. And then we are going to find the slope of V. We get, 0 minus 6 over 0 minus 3, which is -6 over -3, which is also 2. Okay, so we just showed that U and V are equal because they have the same slope and the same magnitude. Be really careful to make sure they're also going the same direction. So notice we're starting here and going to the upper right-hand corner of our graph for both of these vectors. Okay. Okay, we have a lot of information here. I'm going to leave this for you to read And if you have any questions, definitely let us know. But I'm going to just kind of flip through and show you how to do these problems. Here it talks about adding and subtracting vectors geometrically. So if you wanted to graph them to find your answer of adding them, you could do them. Make sure when you're adding, you position the vectors from head to tail. And then when you are subtracting vectors, make sure their initial points line up and then you subtract them. There's two different ways to look at that. You can see those diagrams there. All right, vectors in a rectangular coordinate system. Unit vectors are vectors that have a magnitude of 1. Okay, so we have I and j unit vectors. I is on the positive x-axis and j is on the positive y-axis, and we actually use that for a special notation for our vectors. So when we are representing vectors using rectangular coordinates, vector v goes from the point 0, 0 to a point AB, and it's represented by a bold V equals A times a bold I plus B times a bold J. You would also, in some books, see a different notation that looks like this. Notice the pointed brackets there. Your vector is equal to A times B. Same idea, you're going A steps horizontally, B steps vertically. So it's kind of like graphing a point there. You can find the magnitude, again, by using the distance formula, but remember if this is 0, 0, all you really need to do is a squared plus b squared and then take the square root. And then we have a linear combination there. Okay, let's go ahead and do this. Okay, so the vector negative 3i plus 4j essentially is telling us that we need to go left 3 and up 4. So we're starting at 0, 0, go left 3 and up 4, and then we can draw our ray in. Our vector. That's a really not straight line. I apologize for that. So this is vector v. And then to find the magnitude of v, again, kind of those double bars, we're going to do the square root of a squared plus b squared and simplify. So the square root of 9 plus 16 gives us a square root of 25. So the magnitude is 5. Okay, so again, pretty simple, not too bad there. And we can kind of figure this out as we go. If your initial point is not at 0, 0, you could essentially subtract to find your rectangular coordinates. So x2 minus x1 times I and y2 minus y1 times j. So if we're starting at 3, negative 1 instead of 0, 0, to find that vector, we're going to do x2 minus x1 times I plus y2 minus y1 times j. Simplify it. So negative 2 minus 3 is negative 5, so I have negative 5i. 5 minus negative 1 is 6, so we have 6j. Okay, when you are adding and subtracting vectors, it's kind of like combining like terms. So add or subtract the coefficients for your I and j. So if I have v equals 5i plus 4j and w equals 6i plus 9j, to add them together, we're going to do 5 plus 6 times I and 4 plus negative 9 times j, and our resulting vector is 11i minus 5j. When we're subtracting, we're just going to do the same thing, but subtract. Pay attention to order because that could affect your signs. So for v minus w, we're going to do 5 minus 6 times I, and we are going to do 4 minus negative 9 times j. So we get negative 1i and 13j. Okay, it's that simple, not too bad there. Okay, scalar multiplication, you're just going to multiply, kind of like distributing each term by your multiple. So if I'm going to do 6 times v, we're going to do 6 times 5i plus 4j. So we get 30i plus 24j. And if we have negative 3 times v, we're going to do negative 3 times 5i plus 4j. And we're going to get negative 15i minus 12j. Okay, For this next one, if we have a couple steps here, we're going to do 4v. So we're going to do 4 times 5i plus 4j minus 2 times w, so 6i minus 9j. We essentially distribute and combine like terms. So 20i plus 16j minus 12i plus 18j. Combine like terms. 20 minus 12 is 8, and 16 plus 18 is 34. Okay, we're going to talk about a couple things here, and then I will hit pause and go on to the next video to explain the last few examples here. So, okay, first you need to know a unit vector is a vector whose magnitude is 0. It's called the 0 vector, sorry, not unit vector. 0 is equal to 0i plus 0j. Kind of straightforward, makes sense. And then there are properties of vector addition and scalar multiplication that are very similar to properties of your real number system. Okay, so I'll leave that there. You can check that over. I'm going to go ahead and stop this one and then open up the next video to talk about the last few examples. Have a great day.